Okay. So I hope I'm audible to all of you. Let me see this. Yes. Yeah. Yes. So students, welcome to today's class. I hope I'm audible to all of you. Okay. So let us wait for other students to join on YouTube and also here on Zoom. Okay, that's fine. So good afternoon, everyone. So today we'll be having a motivational session. Got it? Yes. So few students are joining now. Yeah, welcome to today's class, Gayatri. Okay. So let us wait for 2-3 minutes. Soon all the students will join. Okay. Then you'll be having a motivational session by our physics department HOD Vishal sir and 2 of the alumni. Okay, got it? So let us wait for other students. Till then, I'm closing my camera. If you are having any issues, like technical issues, like my audio and all these things are not clear, so please text soon. Okay. Fine. Okay. Yeah. So Sahana ma'am can take now. Okay. I mean, you can unmute yourself and we can start the session. Okay, that's fine, ma'am. Okay.
Yes, sir. Thank you. A very good afternoon to everyone. Happy National Girl Child Day. I'm Sahana El Naik, presently studying in IIT Madras Chemical Engineering second year. I'm the alumnus of Jawahar Navodaya Vidyalaya Hassan, and I had a coaching under I had guidance under Avanti. Yeah, like today today is National Girl Child Day, and to tell about that, आपको सबको पता है कि मतलब गर्ल चाइल्ड डे क्यों करते हैं? Because each and every home, as we all know, at least like our mother or a sister or someone in our family, a girl, how she deals with her family and how what's the importance of her. Like we can say like center of guidance or attraction or anything you can say, because if you take our mother, she guides us in each and every step. So I like to say that when we are guiding others, we have to be educated by ourselves, or we have to be having a certain kind of knowledge in us. So, like government of India has thought to spread this all over our India, so that we celebrate National Girl Child Day to uh, tell to express the significance of the girl child in our country. And also like as much as I know, yeah, as much as I know, like all here are 12 standard girls, I guess. So like from me, the point is, yeah, first you have to aim high and have a proper planning. That is really important. Excuse me, sir, is there anything? Yeah, okay.
Thank you, Sana, for your
Yeah.
good kind words. Ashraf, you can take over now.
Yes, sir.
Yeah. So students, please keep yourself muted. Okay, throughout this motivational session because it's for your well-being. Okay. So I request you to please unmute. Keep yourself muted till this alumni give you a motivational lecture here. Okay, that's fine. Okay.
Ashraf, please go ahead.
Hello, everyone.
Yes, ma'am, you're audible and you're visible.
Hello, everyone. I'm Asra, first year MBBS IMS Hassan. I studied in JNV Hassan from Avanti. Like today's, I wish everyone a happy Girl Child Day. Like, we take a privilege in being a girl, and this session is all about that, I feel. And like, I feel you are all in 11th and 12th. Just the only thing you have to do is now is to concentrate on your studies, work hard, and study whatever you have to. And just if you have any doubts, contact your teacher. They are there to help you to mentor. They'll always help you in any form or any way. Just ask them out if you have any problems. Get your doubts cleared, study well, and like study whatever you're studying now. Like there is nothing else to do for you now. Just study well and get your doubts cleared. Like ask them out if you have any problem, like be it academic or any other thing. They'll help you. Thank you.
Thank you very much, Asra. Sahana, you want to add anything? Sahana, if you want to add anything, you can add.
Yes, sir. Hello. I wanted to add some few things. And what I wanted to say is, like, Avanti has taken a great initiative to help you all. So make use of it properly, because it's not about you. Like, if you are educated, it means you are educating a whole family. So like, you have to focus on your studies, and more than that, everyone has having problem in their life. So like, irrespective of you wanted, you'll not remember those problems, and you'll be proud to be like, when you have overcome all the problems and you have reached where you want to, that you will be very proud to say that I took over all, like, I came over all the problems and I did this. I achieved what I wanted. So it is all in you. Like, you have the strength, you have the power. So make use of it properly. And when, like, while studying, the studying is like, it should be like a tapas. If you're studying, you have to sit for a tapas. You have not to be distracted or just chit chatting or something. Like, you should stop those things right now. So what I wanted to, like, I want to add, what I wanted to is, like, being in a country, and we all are taking a good amount of things from our like coaching centers or from schools. And the thing is, what you have taken is not the matter. Like, what you will give to them after you, like, take. So to give, you have to have something. To have something, you have to be you have to be strengthen yourself, not in terms of only academic, like in terms of each and every aspect, like emotional, physical, mental, every aspect. So you have to be strong, and you have to be like motivating others also. That's really important. So like, bringing up yourself as a great girl child of your family, of this country, is very really important, and that is the significance of this day. So I wish all the best, and take a great lead to lead this country well, to lead this family, and achieve what you want. That is really important. Thank you.
Thank you, Asra and Sahana. Students, once again, I wish you a very happy National Girl Child Day. Thank you very much. Abhishek, you can continue your class.
Okay, sir. Thank you so much. So, students, now I'll be starting a class. I hope you enjoyed this motivational lecture, motivational session. Okay, that's fine. So, thank you for both the alumni, Sahana and Asra ma'am. And like, so, okay. So now we're going to start the class. That's fine. Okay. Yes. So bye bye everyone. Oh, sorry, bye bye HODs of physics department and like both of the alumni. Okay, students. So let us every one of you must participate in this technical poll if it's visible on your screens, students. Okay. So please participate in this technical poll if it's visible. Okay, that's fine. So I hope I'm audible to all of you. And now we're going to start our class. So in the previous class, what are the things which we have studied? So let us see those things first, okay? Because we already have consumed our 10 minutes in this session. So we are having a little bit of like say, what are like 50 minutes, okay? So now let us use those 50 minutes in this class. That's fine. Okay, so let us see first revision things. So in the previous, yes, is anybody is having any doubt? So in the previous class, students, we ended at this recall question, okay? This was the recall question. I mean, there was some question based on the optics. I mean, there was a concave mirror and all these things. So we'll see that recall question again. That's fine. Then we've also, okay, so after that, we'll see some of the combination of questions based on the combination of mirrors. Got it? Then we'll be studying the questions which are based on the combinations of mirrors. And then after that, we'll be studying refraction. That's fine. Is it clear, students? Okay, so after that, if we are left with some time, we'll be studying about apparent depth and the normal shift. Okay, after that, we'll be seeing refraction through glass slab, and after this, lateral shift. So these are your today's topic, students. That's fine. But let us first, as per the slide, the initial slide, but first, this was the first question, that is recall question. So let us first start with this recall question. So this was the question you have, everyone have seen. I mean, and the previous week on Monday, or not on Monday, it was Tuesday, Wednesday. Yeah, it was Tuesday in this Hyderabad session. So on Tuesday, we left at this question. I asked you from the, I asked from all of you that what is the solution of this? What is the answer? So nobody texted, and we concluded like this, key, this will be a homework question. And in the next class, I will take this question as recall. Got it? Is it fine? Yes. So anybody can text the answer now because you are given a lot of time. Say Thursday, Friday, Saturday, Sunday. So 4 days you are having. What you did? Sir, we enjoyed. No. Give me the answer of this question, students. This is a this is a mirror in front of you. So this is what kind of mirror? This is concave mirror. Concave mirror. Okay. See, students, I've closed the video because in between there are some network stucks. That's fine. Cool. So this is concave mirror. So I hope that now all of you might be like, fully motivated and fully passionate for like cracking JEE and NEET and all these things. That's fine. Okay. So this is an object in front of you. It is, I mean, not in front of you. I mean, in front of this concave mirror at 5 centimeter distance. This is origin here. And the radius of curvature here is 20 centimeters. That's fine. Okay. So now we need to apply the formula to find the answer. So if we see here, we're having 1 by V plus 1 by U equals to 1 by F. This was the formula connecting these three things, that is image distance and object distance and this F is focal length. So now we'll be putting these values just in this and we'll get the answer. That's fine. See, what are all these things? V, U, and F. First of all, can any one of you solve this question? I want the answer. Can any one of you solve this question or not? Can any one of you among this class can solve this? Yes or no? Yes or no, students? Nobody's answering. What is this happening? Anyone? Okay, I'm putting the values here. That's fine. Okay. JNV, Ernakulam students have texted yes. Okay, so I'll be putting the value. See, we are having here object distance. U as 5 centimeters. We're having radius of curvature as 20 centimeters. Okay. And we need to find this V. It's very easy. Just put the values. 1 by V plus 1 by U equals to 1 by F. Okay. So 1 by V, U is what here? With the sign and conventions, you will get V as U as minus 5 centimeter. Okay. This is what? U minus 5 centimeter. F is what? F is basically given by the magnitude R by 2. Okay. This is 10 centimeters here. But with sign, this will be like minus 10 centimeters. Okay. Minus 10. So 1 by V equals to 1 by 5 minus 1 by 10. So we get the answer as 1 minus half. Half is a half. This is half. So this will give you V as, students, 10 centimeters plus 10 centimeters. This is our answer of this recall question. Very good. Yes, Jane curriculum, your answer is no, it's not 10 by 3. No. It's 10 centimeters. See, it's 10 centimeters. Got it? Iska answer is 10 centimeter. Yeah, very good. The students from JNV curriculum, like they've given the answer. That's right. What about Swati, Devika, and Gayatri, and Navya, and Pavani, and all the students? What about you? I hope it's clear. That's fine. Okay. Okay, it's typing mistake. Don't no worries. See, sometimes while texting the things or while putting a text in the chat box, sometimes what happens, we are very fast. Sometimes we do mistake, but don't worry about that. If your answer is perfect, then that's a very good thing. Excellent. Okay. If you want, I can give you ice creams also. If you want ice creams, like this. Okay, leave. So now let us start our fresh topics. So there is something about transverse magnification. So what is this thing, transverse magnification, students? A transverse magnification kya hota hai? What is this thing that is transverse magnification? Okay, you want my video to close because it's somewhat not clear. Let this be. So see, for this you have to just remember the formula. Okay, suppose the formula is for transverse magnification is like this. Magnification is equals to height of the image, height of the object minus V by U. Okay, this is the magnification formula. Got it? Yes. बस इसको remember कर रखना है. See, don't think like this. This formula you have to remember always. Okay, I mean, sir, कैसे आया, कहाँ से आया? That's fine. You can just derive from this figure by using geometry. If you want, I can give you the solution. It's already in front of you. Here they are using the property of similar triangles. The property of similar. If you have studied similar triangle chapter, maybe in 10th standard in RD, doing some extra work, okay, then you can solve this. But the main thing is application required. That's fine. So you will see how we'll use this formula in an application or numerical. How we'll use this, we'll see now. So let us see this. See, now you're having a question here that find out the position, height, and type of image. This is what kind of mirror it is? Convex. This is convex mirror. Okay. Clear. Gayatri says clear. That's good. This is what? This point is what, students, by the way? This point is the pole of this convex mirror. Okay. And this is the object. Object is at a distance U equals to this. So U is equals to 10 centimeter. Okay. And here they're asking us to find the position. Position कैसे आएगा? Position कैसे आएगा, students? Position कैसे आएगा? Position will come like this. V से position आएगा. Okay. So we'll find this the position like this. V say we need to find the V. V is for this. Height of the image, you will use this formula. Height of the image upon height of the object is equals to, in case of mirrors, it is minus V by U. I repeat it again. In case of mirror, it is minus V by U. Okay. Got it? So height of the image upon height of the object is equals to minus V by U. You will use this formula here. So now let us solve this complete. Okay. So first of all, we'll find this V. This is the approach. See, focus here carefully on this sheet. I mean, this PPT. First of all, we'll be finding this V here. That's cool. Okay. So let us find this out and this boom. So if you see here, 1 by V, formula was this to find the V, that is the image. ये होता है ना formula. This is an easiest formula in the universe. Okay. So see, object is how much? Object here is given as minus 10 centimeters. And yes, very good. JNV Ernakulam students have given the right answer. Excellent. अगर हम इसको ये वैल्यू इसमें पुट करेंगे तो what going to happen? Minus 10. Focus is 10 centimeters. Since it's convex mirror, since the mirror is convex, focus will take it to be positive. This is positive. This is 2 by 10. 2 by 10 will be 1 by 5. Okay. We'll get V as plus 5. So you can see here with your eyes properly that we got V as plus 5. इसका मतलब क्या है? Image will be here. Plus 5. I mean, image is virtual image. So we'll call this image as, because it's in a mirror word, it's a virtual image. Okay. And now we got one answer, by the way. Okay. We got the position of the image that is virtual, that is plus 5 centimeters. But what about height of the image? Height of the image का क्या करेंगे? What we'll do about the height of the image? So we'll use this formula now. Okay. Height of the image upon the height of the object. See, sign and conventions कैसे लेने हैं? How to take the sign and conventions? If you start from the principal axis, if you go top, this is the positive direction. If you go like this, this will be negative direction. Same on the other side of the mirror, whether it is concave or whether it is convex. Okay. So here also above will be positive, down will be negative. So these are the things. Got it? So now apply the formula and get the answer. Yes. So JNV Ernakulam students have given the right answer. Excellent. Very good. What about Gayatri? Gayatri must also participate. No, I mean, okay. Gayatri also got the right answer. Excellent. What about other students? What about the other champions? What about Swati, Kavya, Anjali, Kambi, and all the students? Okay, I may be wrong in pronunciation of your names. No issues. But the main thing is this: you all must do this question. Solve this question. Okay. I'll solve this question now. So I'm having the values U as plus 10, V and U as minus 10, sorry, and V as plus 5. So see here carefully, U as minus 10, V equals to plus 5. So height of the image upon height of the object minus V by U. So minus 5, U is how much? Minus 10. Okay. And you'll get this as half. But we need to find this height of the image quantity. Height of the object kitna hai, students? Height of the object is equals to 4 centimeter. Okay. Positive. So जब हम इसको solve करेंगे, you will get like this 4 upon 2. That is 2 centimeters. Okay. So height of the image here is equals to 2 centimeters. Got it? This is the height of the image. This is the height of the image. It is equals to 2 centimeters. You're having the height of the object as, you can see here, object का height कितना है? 4 centimeter. और height of the image कितना है? 2 centimeters. Yeah. Type of image is virtual image. Okay, now we'll conclude one thing from this question, by the way. There is one conclusion for all of you. Conclusion. This is what conclusion. What's the conclusion, students? So conclusion is like this. What is the conclusion? Conclusion क्या है? Conclusion is this. कि ऑब्जेक्ट का हाइट तो था पॉजिटिव 4 सेंटीमीटर और ऑब्जेक्ट का डिस्टेंस जो कॉन्वेक्स मिरर से इसमें था इट वाज minus 10 centimeters. Okay. Height of the image here is plus 2 centimeters. That is half of the height of the object. Okay. And this is the height of the image. This is the object. Okay. And V was actually plus 5. So can you observe one thing? It's a very beautiful observation. Are you able to observe one thing, students? Focus here. Let me demonstrate it. So what it says, if you see in this, what the thing is, see, इसमें क्या है? Object 4 centimeter, image 2 centimeter. What does it mean? It means height of the image is half of the height of the object. Height of the image is half of the height of the object. Okay. उसका आधा है. If you see the object distance, object is at 10 centimeter. An image is at 5 centimeter. It means also the distance from the convex mirror, but on other side, that is virtual side, image is at half of the distance in magnitude from the object. Okay, so दोनों ही चीजें half half है. That is, both of the things are half half. That is this. If you see here, image height is also half of the object height. Also, the distance of the image is also half of object distance. Okay, in magnitude. Got it? Now, students, one more question. Now we have two kind of methods. If anybody asks from us, if anybody is asking from us, by find the object distance, you can find this out. If anybody is asking from you, height the image, height of the object is like this minus v by u. Yes, do not. You also you can find now. Height of the image is an object. But if someone is asking from you to find the velocity of the image, how will you find? आप कैसे करोगे? Now how will you find the velocity of the velocity, sir? No, sir. We are having the formula just for the distances. One formula is this. I have studied also, yes, somewhat this for f upon r by 2 in magnitude. And one I've seen this, which is connecting the heights plus 5 minus 5 with x minus x. I mean, image and object distance. So these two formula till now I have studied, sir. But velocity of the object, it doesn't make sense to the theory. I mean, according to the theory which I have studied. So this is not according to me. Just cut this question. No, students, you need not to cut it. Don't remove all these things. Okay, so we'll solve now. We will solve this question now. But before solving this question, we need to go through a concept. Before solving this question, students, we need to go through a very beautiful concept. What is that concept? I mean, you will use just an equation of 1 by v plus 1 by u equals to 1 by f. Then you will differentiate it, and then you'll get a relation, a formula, a well generalized formula for all kind of numericals. Then we will use that formula as an application in this numerical for finding the velocity of the image. Okay, is it fine? Yes or no? Yes or no? Yes or no? Yes or no? Okay, students, so let us first derive that formula. So write the heading in your notes. Gayatri says yes. Good. So write the heading in your notes, students. Velocity. Okay, let me use different color. White color is fine for this. Write the heading velocity of image. Velocity of image when object is moving, also mirror is moving. Okay, so if the object is moving some velocity, this is the velocity of the object. Velocity of image is this. You'll write velocity of image. And suppose velocity of mirror is vm, we write velocity of mirror. It can be anything. Either it can be concave mirror, either it can be convex mirror. Okay, got it? Yes. So now students, we're going to derive that. Just look here carefully, okay? Look, a few students have put a text. Let me see, what is it? Yes, good. But before that, let me see on the YouTube what they're doing there, okay? Just hold us for a second. Let me look there on the YouTube. Yes. So here we go, here we go, here we go, here we go. Just wait for a second, students. Just wait for a second, just wait for a second. And So here we go, here we go, here we go, here we go. Just wait for a second, students. Just wait for a second, just wait for a second. And yes. So students, welcome to today's class. I hope I'm audible to all of you.
Each and every home, as we all know, at least like our mother or a sister. A very good afternoon to everyone. Happy National Girl
Okay.
Child Day.
Okay, students. So let us derive it. Okay. So we were here to find the velocity of image. That's fine. So see here, 1 by v plus 1 by u equals to 1 by f. If you see this formula carefully, what is this v, u, and f? F is of course constant for a particular mirror. If you take concave mirror, for that also f is constant. If you take convex mirror, for that also f is constant. Okay. So now we'll differentiate this left hand side. इसको differentiate करेंगे तो what's going to happen? Minus 1 by v square dv by dt, and this is minus 1 by u square du by dt equals to 0. Is it cool? Yes. So now we take this. What the students are doing now? Now I will take this dv by dt as what? Devika, please mute yourself. Okay. dv by dt means what? It means velocity of image with respect to mirror. Okay. du by dt is equals to what? Velocity of object with respect to mirror. Okay. So now we'll write like this: velocity of image with respect to mirror minus v square by u square, velocity of object with respect to mirror. That's fine. Got it? Now let us apply this formula. Students, first of all, tell me, are you comfortable with this formula? Everything is okay. Are you comfortable with this formula or not? Text fast, students here. Are you comfortable with this formula? See, if you'll text, then only I can proceed further. Otherwise, it will not make sense. Otherwise, it will not make sense. Okay. इसको बस differentiation करना है, nothing you have to do. Okay, I'm applying this formula. Okay, so let us see this question. This question में हो क्या रहा है? What is happening in this question? What is happening in this question? Okay, so if we see here, velocity of the object is given here. Take this to be positive, this to be negative. Okay, so velocity of object here is given as 2 centimeter per second positive. Velocity of the mirror here is given as, it's basically a concave mirror. For your information, for your kind information, it's concave mirror, and the velocity of the mirror is minus 1 centimeter per second. Focal length here it is given as 10 centimeters. Okay, and it is negative because it's concave. Object distance here is minus 30 centimeter. Okay, so first of all we'll find the v. V will be like this. Solve करेंगे क्या आएगा? This will be minus 30 minus 10. So when we will solve it, ultimately we'll get like this. That is minus 3 1 minus 2 by 30. It is 15. So we get here v equals to minus 15. It means finally, if the object starts like this, having u equals to initial at time t equals to 0, image will be at minus 15. It will be in between somewhere. It will start its journey from here. So either the velocity vector of the image will be here, or either the velocity vector of the image will be here. So I don't know where it is. I'm confused. Okay, so let us directly apply the formula here. So when I'm going to apply the formula, you can see here that this is the application of the formula here. I'm applying the formula only in this space. So formula is this: velocity of the image minus velocity of mirror minus v square by u square, velocity of object minus velocity of mirror. Okay. Velocity of image कितना है? I don't know. Velocity of mirror कितना है? -1. V square कितना है? V is -15 square. U कितना है? U is 30 minus square. Object का velocity कितना है? It is 2 centimeter per second. Mirror का कितना है? It's again -2. Solve this. So velocity of image will be here +1. This is 1/4, and 1 minus is there, and this is 3. So you get here, students, velocity of image with respect to u, that is ground frame, is equals to minus is 1, by the way. Okay, -3/4 -1. This is -7/4 centimeter per second. And it's a perfect answer. No need to worry. Sir, ye sahi to hai ki nahi? No, it's perfect. This is the right answer. So we'll say that this image will be moving in the negative direction, that is this direction, with this magnitude, 7/4 centimeter per second. Please mute yourself. Who's this? Who was this? JNV West Godavari students. No, you are fine. You haven't unmuted yourself. You haven't unmuted yourself. Okay. I'm talking about other students. What about other students? So, okay. So did you understood this question or not? समझ में आया है question? Is this question clear to you, students? Please text fast. I hope the solution is clear. The solution is -7/4 centimeter per second and the negative direction. And we know now how it is. It's not just a fake thing. This is not just by the seeing and I've written the random answers. No, we have used a proper methodology. We're going through this formula. Then we have gone through this velocity formula. Okay. So yes, one of the students is texting me. Gayatri says yes. What about JNV what is this? Arnakulam. What about JNV Arnakulam students? What about other students? All of you must participate. See, students, if you are not participating, how, I mean, you understand this thing. You must participate in the class. This shows your concern towards your subject, not just about the physics, but also about cracking your competition exam, that is NEET and all these things. Also, it will be beneficial for your NCERT, terms 2. है ना, ray optics तो आएगा ही ना terms 2 में. So what's the issue? Be focused. See, don't take it as a burden. Be happy, chill, and then study. Got it? So I hope it's clear. I hope it's clear. Yeah. So Navya says, sir, we chill. Like, I mean, you're happy. Swati is okay, fine. Okay, so I think all the things are clear now here. So now let us move towards the next slide. So so now we have reached here. So there is also one kind of numerical. I mean, in the series of solving, the numericals based on mirrors, that is concave or convex. Just hold on, student. Okay, so on the series of solving questions which are based on concave mirror, okay, we'll also solve this kind of question where the Cartesian coordinates of a particle is given. Okay, so what is given here? Cartesian coordinates of the particle is given. Cartesian coordinates of the particle is given. Okay, and they're asking from you to find the Cartesian coordinates of image. So how will solve these kind of questions? Any solution? Any guess? Okay. So how will be solving this kind of question? Where you are given an object, point particle kind of, uske coordinates you are given, y and x coordinate, and now they're asking you to find the image coordinates. What are the image coordinates? They're asking you to find this. Any one of you? Okay. Anyone? So okay, so let us see now. See, I'll solve this question completely for you. No need to worry कि sir कैसे करना है कैसे करना. No need to worry this. Okay. I'll be solving. So just be focused here. See in this, what is given is this a concave mirror. Okay. And let me take the black pen. This point is what? This point is the pole of this concave mirror. And it is basically on the origin, that is 0, 0. ये point कहाँ पे है? It is on the origin. Okay. And the object is this. This object is having the coordinates as -41. What are the coordinates of this object? It is -40 and 1. So it says us was कि sir इसका जो image का height होगा, I mean sorry, the object का height we can treat it as height of the object as +1 centimeter. And if you talk about the distance, it is this 14 magnitude. Okay, so basically they're asking from us the image x and y. You can say like this: image ka position, x denotes the position and y denotes what? Y denotes the height of the image. Okay, so this question can be interpretation, the interpretation can be done, or this can be translated, or you can say in more better word that this question can be modified and can be asked in this sense: ki find the position and height of the image. See, no need to worry, we are also having a very cool, interesting animation of reflection process, but just for that we have to solve this question. Okay, I mean this is the pending question from the series of the questions based on spherical mirrors, that is concave and convex. Okay, find the position and height of the image. So we'll see here position matlab v, height of the image matlab hi, yellow color. See, we are having the formula 1 by v plus 1 by u equals to 1 by f. ठीक है, f क्या होगा इसमें? What is f? f is focus. Focus का वैल्यू कितना है? Radius of curvature by 2. Okay, 10 by 2. This is 5 centimeters. ये कौन सा mirror है? What kind of mirror is it? What kind of mirror is this? This mirror on your screen is what? It's concave mirror. Okay, so this will be having negative thing here. Of course, now we know this thing, concave mirror is curved towards like this, such that the center of curvature will be negative as measured from the pole. So of course, focus will also be negative. So we'll get this f value as negative. Now put this value here. Object kitna distance pe? -40. X coordinate of the object. Focus kitna distance pe? It is -5. जब solve करेंगे, they will get like this: 1 by 40 minus 5. Okay, so from this you can conclude like this, that is 1 by 5, 1 by 8 minus 1. So this will be -7 by 8, 1 by v. Okay, so from this what you can conclude? You can conclude like this: the answer will be -40 by 7 centimeters. Okay, so through this you can say like this: if the mirror is concave as on the screen on the left hand side and image is at -40 by 7, matlab image yahin pe hai on the same line of the object. Okay, so the position, bas uski position kya, it's 40 by 7 in magnitude. And one thing is clear, see students, one thing is clear here, ki the image is real image. What type of image is it? Is real image. Okay, and if we talk about the height of the image, so we get one thing from this: we get the x coordinate of the image, that is position. Position हमारे पास आ गया, that is x coordinate. We got the position here, that is x coordinate, students. Okay, so why we need to find now y. Okay, so from this we get x coordinate here, that is -40 by 7. That's fine. Just wait on. So we need to find y coordinate, that is the height of the image. How you'll find? We know the formula. What was the formula, students? You know, every one of you know in this class. What is the formula? Height of the image, sir, upon height of the object minus v by u. put these values directly in this, you'll get the answer. हमें पता है कि height of the image हमें नहीं पता, हमें height of the object पता है. Yes sir, we know the coordinate is 1 centimeter. Very good. One student have texted the answer. Gayatri, your answer is very good. Okay, you say sir, y coordinate of the object is not the same as y coordinate of optical center, so wouldn't value you change? No, it's not like this. Optical center lens, in lens the conditions are different. This is concave mirror, it's a mirror part, it's not a lens part. Lens में conditions are different. You got it? And that is not optical center, it is a pole. In mirror we say as a pole. You will not change. Very good. So this is how, you know, I mean, it shows that your brain is really working in the class. Your brain really works on the class, whatever is taught to you. So that's excellent. Okay, Gayatri, that's good. Very good. So if you talk about the height of the object, if you talk about the, okay, Navya got the answer. Very good. Okay, Arnakulam students understood it. That's fine. Navya, your answer is right, I think. So इसमें apply करेंगे 1 centimeter is the positive here. V is minus 40 by 7 again. U is minus 40. So minus minus cut, 1 cut. This is minus 1 by 7. It's minus 1 by 7 to me. Is it minus? V is negative, U is negative. We will with this. So you get from this minus 7 centimeter is the image height. That is inverted. So in this picture, you will draw the image like this. That is, of course, it is here. Of course, it is at this position, but it is inverted. That is minus 7. Okay. So the coordinate will be like this. That is minus 40 by 7 minus 7. This is the image. Students, is this thing clear? Please tell fast. Here I image with green color I'm drawing here. The point. Is this thing clear? So when you keep a object, a point kind of object, which is having the XY coordinates minus 40 and plus 1. So you'll get the image as shown by this green color point, which is having the coordinates minus 40 by 7 minus 7. Is it fine? Yes or no? Please text students, is it fine or not? I hope it's clear. I hope it's clear. Okay, so Gayatri says clear, very good. So after this topic is remaining, but students, for you people, I'm giving you, kind of relaxation here. So for you people, there's a relaxation here. So we'll see this topic in the next class. But before ending, we'll solve questions based on this topic in the next class. You can also take this question as a homework. Okay, because I tell you, you cannot solve this question if you want. But for all the students who are facing difficulties in combination of mirror questions, we'll see afterwards. Okay. So basically, what is it? If anybody want to solve, I'm giving you a hint. Here we're having a concave mirror. Okay. And this is what kind of mirror? It is plane mirror. Okay. So whenever there is a combination of mirror, so due to multiple reflections, image will form, and finally we'll be having the one image. In this kind of question, the examiner or the questionnaire will ask you this final image distance from any particular point, maybe from the pole of the mirror, plane mirror, pole of the spherical mirror, or maybe from the center of the plane mirror perpendicularly. Okay, it can be anything. So this is a homework for you. If you can, you can solve. If you don't want, I mean, you're not able to solve, leave this perfectly. Leave this perfectly, 100%. Okay. Now, students. Okay.
Topic.
Now I'll be directly going towards a reflection. So are you ready for the reflection animation? Now I'm having for all of you a gift on this National Child Girls Day. Okay, like an animation. It's not a gift, but it's for all of you. I mean, even if it's not a special day, we'll make this day special with this animation in this class. This is a very good animation. Are you ready for the animation? Yes or no? Are you ready to see the animation? See, you might be thinking reflection kya hota hai? So this animation will teach you reflection in a very funny way. This animation will teach you reflection process. See, as we have seen reflection, there is something known as reflection. So this animation will help you completely in a very funny way that, like, that if you're watching some funny cartoons or animations like Shin Chan, Doraemon, and all these things, but not like Dragon Ball Z, okay, or Naruto. It's like funny, like Shin Chan and Doraemon kind of, somewhat Doraemon, but Shin Chan you can say most probably, okay. So let us see this animation. I hope all of you are ready. Kambi, Nilima is ready, Gayatri is ready. That's good. Okay, so I'm launching the animation. See, I want to give you a little bit of the information about this animation. You can see it's a magic hat. Okay, and this is magic chadi, kind of magic stick. So there will some funny cartoon will appear here. He's very proud of his this magic stick. He's very proud of his magic stick. This magic stick. Okay, and then he uses his magic hat and magic stick mainly to produce many things from this magic hat. Okay, but what happens? You will see now. So here we go. So I'm launching it. Here we go. Here we go. So I've launched it now. You can see it's visible.
Topic: refraction of light.
Observe it carefully.
Why does a pencil look bent in water? Wow, that was a very cool magic trick. Now check this out.
Oh.
Hey, stop crying. Your magic wand is not bent or broken. Look, it is safe. But do you know why your magic wand appeared bent in water?
Oh.
It is because of refraction of light. Refraction of light is the change in direction of light when it passes from one medium to another obliquely. So, what do you think are the two media here? You don't know? No worries. I will tell you. They are air and water.
Oh.
When the light rays coming from the tip of the magic wand pass from water to air, they change their direction. That is, they get refracted. When these refracted rays reach our eyes trace them backward as straight lines. Due to this, the rays appear to come from a point slightly above the original position. Hence, the magic wand appears to be bent in water.
Oh.
Similarly, like the magic wand, a pencil appears to be bent in water.
Okay, students, so I hope you enjoyed this animation. So what we have learned from this animation? Can anyone text me? Or you want me to explain this animation? Can anyone of you text me what you have learned from this animation? Anyone? Anyone can text in the chat box what you have learned from this animation. Then we'll end the class soon. Okay, let me explain this thing. Hold on. So just focus there on the animation thing. See this. If you focus on this person, he feels bad when like his magic wand goes into this ball of water. He thinks if like, yeah, now you can see this picture. Okay. I hope you're able to see this picture properly. So what is happening here? That this boy is crying. Why is crying? Because he's feeling that, yes, refraction means bending of light. Navya got it. Navya got the point. Very good. Excellent. So this boy is basically feeling bad. Why? Because he thinks like this, his magic wand, which was earlier straight like this, is now bent, or it's like broken from a point here. So that's why he's feeling like this. I mean, he's feeling bad because to his eyes, it's appearing. Okay. See, I think I made you by mistake the co-host. Don't do anything on the slides. Okay. So here, what is happening? He's feeling the magic wand is actually tilted, but actually it's not. What happens is basically when light ray passes from medium such as water, a denser medium, to a rarer medium, it bends away from the normal. And when it is traced back, the object appears slightly above from the initial position to our eyes. Okay, and this process is known as refraction. So now let us see this thing. Now let us see this definition and then we'll end the class. What is this refraction of light? Refraction of light is explained like this: deviation or bending of light rays from their original path while passing from one medium to another medium is called refraction. Remember this definition and write this in your notes. What does it says? It says किसी भी light ray का bending होना, deviation होना from their original path while passing from one medium to another. Okay, and what is that property or that optical property that will decide its deviation? What is that property or that optical property that will decide its deviation? The optical property is refractive index. That optical property is refractive index by the way. Okay. So it is due to the change in the speed of light as it passes from. Okay, let me explain you one thing. Suppose, okay, if we see the speed of light in air or vacuum, remember this point. This is the last point of today's class. If we see the light in air or vacuum, it is having speed is equals to c, that is approximately equals to 3 into 10 to the power 8 meter per second. In some books you will find like 2.99999 into 10 to the power 8 meter per second, but that's the same thing, no? Okay, now again, if this light ray is not in this air or vacuum but it is in the water or some liquidy material, okay, then we'll say that its speed will be not this, but now the speed of this light ray will change by c by eta or c by mu, where this eta and mu are just symbols and are equal length and is known as an optical, and is known as or given by the name of an optical property, like denoting the optical property or resembling the optical property, name is given as refractive index. Okay, so for different mediums we are having different value of refractive indexes. Okay, for water we are having the refractive index 1.33, for air we are having a refractive index 1, for oil we are having a refractive index 1.5. so as the refractive index increases, speed of light in that medium decreases. So this, see this, what it says, more, cut this ls, more refractive index implies less speed of light in that medium. Okay, जैसे जैसे mu बढ़ेगा, that is refractive index will increase, speed of light in that medium will decrease, because speed of light in a particular medium is inversely proportional to refractive index of that medium. That's why it says when refractive index is more, speed of light in that medium is less. Okay, and when the refractive index is less, speed of light will be more. Got it? Okay, and one more thing to understand before ending is this. So due to this, denser and rarer medium comes into existence. Denser and rarer medium. So what is denser medium? Denser is the medium, you can say, which is having the more refractive index. So denser, optically denser medium is more refractive index. Optically rarer medium means less refractive index. Okay? I hope it's clear. So students, that was about today's class. In the next class, we'll see laws of refraction. We'll solve a numerical based on that. Of course, the thing which we have left, that is combination of mirrors. We'll see that topic also. Okay? So that was about today's class. Now I'm going to end the class. If anybody is facing any doubt, please can text in the chat box. Yes. Thank you so much for your attendance in today's class. I hope the slides are properly visible to you. If you're facing any doubt, please text, because the time is soon going to, it's time up. Okay. We are only having 1 hour allotted to take this class, and I'm going to end this class now soon. If you're facing any doubt, you can text. Otherwise, you can leave the class. Bye-bye. Okay, bye, JNV Ernakulam students. And let us see what about other students. If anybody is facing any doubt. Yes, bye, admin, bye, Navya, bye, all the students. Okay. Yes, you can leave the class if you're not facing any doubt. Okay, so you're saying thank you, class was very useful. Okay, same here. Okay, class was really useful. Yeah, I mean, we have seen the animation, we have enjoyed it. So now I'll be ending it. Bye bye. Goodbye, everyone. Okay. We'll meet in the next class. Till then, study well, be happy, enjoy your days.